All right, I'll get started right away. So thank you so much for having me, first of all. I'm really excited to be here. Over the last year, I've been so happy to see more and more events finally starting to come alive again. So it's nice to finally see other people besides the people you work with online. But yes, today I want to talk to you about an intro to generative art with Scala. And just a little bit about myself. I'm actually an American that lives in the Netherlands. As it was mentioned, I work for Lunatech, but I kind of have an interesting role where I work for Lunatech, but I also work for the Scala Center because Lunatech sort of just lends me out directly to the Scala Center, so I work for them full time. And I primarily work on Scala tooling. So some of the things that I've most worked on has been Metals. I'm one of the original maintainers of Metals, the BSP, which is Build Server Protocol, Neobin Metals, because I'm a big Neobin user. I maintain S coverage, and then I contribute to Dotty and a bunch of things. Basically, where all of these converge is where I hang out, is the tooling portion of all of this stuff. I also have a podcast called Tooling Talks, where we talk about tooling, and then I also enjoy a bunch of other stuff in my free time, like art, music, cooking, wine. So generative art, what is it? How many people are you familiar with generative art? When you hear generative art, are you yeah, I know what that is? 2 people, maybe? More than that, okay. And I have a feeling that a lot of people think AI generative art, which is different than what we'll talk about today. But in general, generative art is a form of artistic expression that involves using algorithms, computer programs, or systems to create artwork. It's often characterized by use of rules, some randomness, then some sort of automated process that generates visual or audio-visual content. And then the more you sort of dive into this world, the more amazed I personally am, because you have just everything, every sort of generative thing imaginable is out there. But here's a few things that I wanted to just show as an example, which will give you at least a small idea of some of the stuff that we'll talk about today. So this is a piece by Tyler Hobbs, and I'll talk about Tyler Hobbs in a little bit because we're going to basically copy one of his tutorials, but do it in Scala. And this is a piece called Days Fade. This is one from Jack Rusher. I don't know if people know who Jack Rusher is, but he's a huge person in the Clojure community, and he makes some of the wildest stuff imaginable. He used to work at Bell Labs and has a really long history of just wacky stuff. So really, really like a lot of the stuff that he creates, because a lot of times he'll use code to create something, and then he'll actually 3D render it as well afterwards. So it's pretty cool. This is another guy called WestGenArt, which does a lot of generative art, but then also does shader work and just makes them come alive, basically. So his stuff is super, super rad. And then there's also another individual called John Jeff, who has a lot of stuff like this, and this was a good example of plotter art. So another thing a lot of people do is they'll take generative art, and not only will they generate it visually or digitally, but they'll also then take that to a plotter, and they'll literally plot it out. So you see a physical piece afterwards, which is pretty cool. How do they do this? And this list is humorously small, but some of the things that you might be familiar with is processing, which is probably the most well-known-ish maybe, just because there's just a crazy amount of information out there about it. P5.js, which a lot of JavaScript people may be familiar with, which is actually a project underneath processing. Doodle, which is coming from the Scala ecosystem. Cinder, which is from the C++ ecosystem. And literally just anything that you can generate graphics or sound with could be used for this, because I don't know how many people are on Reddit, but there's a subreddit called Generative Art, and if you scroll through some of the stuff on there, you literally, it blows my mind, what people can create, but also all the crazy stuff that people use to generate art. So it's pretty wild. And at this point, you might be asking yourself, well, why do you do this? Or why are you even doing a talk on this? Because this is not the normal type of talk that I would do. I typically always do talks on tooling. But the simple answer is this is super fun to me. Since January, I've been working full-time on tooling for my full-time job. So I feel it sort of changed what I wanted to do in my free time a little bit. And I wanted to branch out, still do something tech-related and related to my other interests. And generative art just seemed to be the perfect thing for me. And then you might be asking yourself, well, how do you get into this type of thing? And I'll show you, but I do want to mention Tyler Hobbs, who was the artist of the first piece that I mentioned. And he is really interesting because not only does he do tons of work, but he also does tons of tutorials, or not necessarily tutorials, but more of like a look at the artist's mind, like how do I think of these things, or like how do I approach certain things. And he had this article from a few years ago called Flow Fields. And if you look at much generative art, you'll start to see like some patterns. I'm going to scroll through all this because I don't want to show you some of those things. But you start to see like some similar things amongst different pieces that a lot of artists have. And then you start to realize that everybody, like not everybody uses the same ideas behind the scenes, but they sort of start in the same place. And sort of like the easiest place that a lot of people will tell you to get started is with something called flow fields. And that's what we are going to sort of explore today. So against my better judgment, I'm going to like live code the whole thing basically, because that's pretty much it for the presentation. And I want to do this for a couple of reasons. One, because I think it's a pretty cool way to demonstrate a few things that I'm going to be using. I was a little bit annoyed when I first wanted to use processing with Scala, because under the hood, processing is a Java library. So in my mind, I was like, cool, so I'll just include the jars and just go, basically. But they don't publish them in the Maven Central, which is a bummer. They used to, the old versions, but the primary maintainer of it didn't want to like maintain that, and somebody then published it under a different name, and everybody thought that was the official one. And then they started to get like tons of complaints and things didn't work, and he's like, I didn't even do this, so it was a big deal. So they don't publish it for the new ones. And they sort of try to push people to use the processing IDE, which is like an all-encompassing thing that allows you to download an IDE. It's kind of a crappy IDE, but you get to see the visuals right there. But anyways, I wanted to use NeoVim to show that you can sort of mimic that same type of thing. But I also wanted to create like a Gitter template that would allow people to also try the same type of thing. So if you're interested in processing and you want to try it out, this Gitter template will do all the setup for you, because behind the scenes, what we actually had to do was like download this entire application, figure out in the application where the jars are included, take that jar out, but then I realized there was no source jar, so then I had to pull that processing down itself and create the source jars and then package them all together. So this does all that for you, so you don't have to like go through all that nonsense like I had to. And what we'll be doing is actually going through this repo. So the bottom one, and that's what the QR code links to, is actually like a seven or 8 step different Scala files, and we'll basically go through every single one of those to show some things that we'll go over. So we're going to go and we're going to try this out. It's a little bit, you might have to go like this to code, so bear with me. Okay, but like I said, we're going to start completely from scratch. So we're going to use G8, which most people might be familiar with, just to pull down that first repository that I talked about. And this will set up a very basic project for us. So we'll call it Scala in the C. All right? How many people have used scala-cli, by the way, too? Like, I'm curious if I have to say much about it. Very few people? Okay, scala-cli will become the new Scala plan, so you should become familiar with it. That's my sales pitch, basically. But it's a really cool minimal build tool thing that you can use to build stuff, Scala stuff, without having to use a build tool, basically. And the project looks very minimal. You have a lib, which inside of it has those jars that I told you about, which I unpacked already. And then you just have a project file and a main file. And with scala-cli, if you're going to use like an editor, either Metals or IntelliJ, you'll want to get a BSP file, and the way you do that is scala-cli. I use a shortcut scli, but really it just stands for this. And you can do setup IDE, this workspace, and then you get a BSP file. And that's it. So if I open this up now, we'll open up project first, and you'll see that I'm using Scala 3, 17, I'm including some processing core jars, and then a few other things. And the main application here, or the main file, is really small. We just have a main method called example that calls this PA applet main, and you give it what class that you want to run, basically, which is this very small thing. And you'll notice that every processing application will have two main things. They'll have settings, which is something that's ran before any type of generation happens or anything does. And then you have this draw method, and this draw method is what is actually like giving you the picture that you're about to do. So if I would actually just run this, you'll get a nice little pop-up here on the screen. Follow my mouse, and this is kind of cool. Like that's it. Like that's the starter thing basically. And you can kind of like really easily just start to play around and create stuff. So like if you would do like width here equals 1,000 instead, and we can do the same thing for the height. And then instead of these, we just do width, and instead of this, we do height. Oops. And we run it again, you'll notice like now I got a big one. So it's pretty simple, right? So you can pretty quickly see like what's going on. And what we're going to do is dive into the article that Tyler Hobbs created, and he basically goes into talking a little bit about what flow fields are, and step by step introduces you how to make them. And it's like surprisingly, I don't want to say easy, but like surprisingly comprehensible, even if you're not familiar with it at all. And the general idea is that flow fields is just one big 2D graph. And on this 2D graph, you have a whole bunch of points amongst the graph. And at every little like square point, you basically want to store an angle. And then based on how that angle is, you can trace the flow of angles, and hence you have like a flow field, right? So not too crazy. And just for some time, I'm going to try to copy some stuff here, which will make it easier. And what we're going to do is we're going to not do that. That's not what we wanted. Bad if the whole thing didn't work out. No. Good. Okay, so we're going to start with a grid size of 1,000 by 1,000. But if we use that to actually draw our lines and stuff, like every line would like stop at the end of 1,000 and it would look like really jagged kind of. We don't want that. So we actually want our grid to be a little bit bigger. We want it to like extend, you know, a little bit more to left and right, top, bottom, so it doesn't end that way. And we also want to figure out like what is the resolution of this grid? Like how large are these gridded things all over this thing? We have like really small circle or squares or really large squares, and we'll call that resolution. And in order to do this resolution, we can use the width or the height since they're the same. And we'll just say we'll times it by 0.1. And we want it to be an int here, so we'll just go to int. And then we will basically figure out how many columns we have and how many rows we have by using the right, left, and the actual resolution. So something like this. So we'll take the right x, left x, divided by the resolution. Same with the y, and that's what will give us ultimately our number of columns and our number of rows. And the grid that we're going to create here is just going to be an array of dimension, and we want this to be some doubles, and you'll see why later. And we're going to say, num of cols, num of rows. Okay, so this is the grid, the setup of our grid. And again, if I run this, same thing, but I didn't change anything in the actual like draw method, so it doesn't really do anything extra. Okay? And where we are actually going to start changing some stuff is going to be down here in the draw method. And just for, again, a little bit of sake of time, we're going to basically draw out this grid, and we're not going to necessarily draw the grid. What we're going to do is actually draw arrows inside of the grid to make it a little bit easier. So if I paste this, here's a little draw arrow method. If I go a little bit smaller, can people still see that okay? So I don't want to go too into the details of what we're doing here, but in at least processing, and especially when you're using grids, there's like this interesting concept of drawing on the 2D plane that they have. And it's basically what you see this push matrix and pop matrix thing, which you see down here. Because often, like when you first get started, you kind of have this idea in your head, like, well, if I have like 1,000 grids everywhere all over this thing, and I have to like draw a shape in every grid, I have to like point, like I have to have like 5 or 6 different points and to draw an arrow, and I have to do that in every single grid. Like that's going to be a whole lot of like figuring out. So a way to get around that is instead of drawing all over the grid, you just move the grid around and draw one shape one time all over the grid. So that's what this does. Push matrix basically says, hey, we're going to start moving the grid around, and we're going to translate it to whatever place you want it to be on the grid. We're going to rotate it, whatever degree you tell me to rotate it, and then I'm just going to draw one arrow. So the drawing is actually pretty easy, but we have to move the grid all around to draw the same shape at the time. But at that point, it's not super, I would say you don't have to worry too much about that. So we're just going to actually just get rid of it. And we're going to get rid of this line here. And now what we're going to do is we have to iterate through this grid that we made, right? So if we go through this, every single column, and 0 until the num of columns, and we're going to do something for every column. But we're also going to want to do the same thing for rows. So for every row, for 0 until the num of rows, do what? What do we want to do? We basically want to make an angle and draw an arrow that corresponds to that angle. So we need to get, first of all, the x and the y coordinate that corresponds to where we want to do this. Because again, remember we have this resolution thing which kind of changes things around a little bit. So for our x, what we can do is we can take the column and we can times it by the resolution, which will then give us the actual x coordinates. We can do the same thing with the y in the row. So we can say that y equals row times resolution. And now we need to get an angle. And for a really easy way to do this would just be we're going to use Scala math pi. We're going to times it by 0.25, and there we're going to have our angle. So we're going to call the draw arrow method that we created a little bit ago. We'll give it the x and the y coordinates. We'll give it the angle that we want to draw. And then we'll give it how big we want that arrow to be. And for now, we'll just say whatever the resolution is. So again, there's not a whole lot of code here. Does it kind of make sense so far? We created this big grid. Now we're going to iterate through all the columns and the rows in the grid. We created an angle, and we just want to draw an arrow showing that angle. So if I run this again now, now we have some semblance of arrows pointed in one direction, but they're pretty huge. So we don't really want them that big, because if you tried to trace these arrows, your line would just be huge, big, weird looking thing. So we need to change our resolution. So really simple to do. We can probably just go 0.1 here and do it again. Okay, now we have way smaller arrows. And we can, you can imagine the lines will be much more flowy, like you want them to be with flow fields, right? But there's a couple different things that's boring about this, right? Every single arrow is the same way. You don't really want that because all your lines would just be exactly the same. That's kind of boring. So we need to change how we do our angle. So we put an angle here, and instead of doing pi times 0.25, we want them to maybe curve as it goes down, and we can kind of just use a little bit of basic math to do that. So we have, let's say, a row to the double, and we just want to divide that by the number of rows to double, and maybe we'll just times that by 5. Now if I do this again. All right, now we have arrows that start this way, and now they start to slightly curve, and by the bottom you see that they're pointing down. I don't know if you can actually see that or not, but that's what they're doing. So now we have a little bit of curvature, which is pretty cool. But that's also just boring because it's just lines. We actually want to start tracing some stuff, so we can do that as well. So in order to actually trace some stuff, we can't just print out this arrow anymore. We need to actually store the angle and then iterate through it a second time basically, and then start plotting dots or line amongst those arrows, right? So we're going to change this around a little bit. So we're still going to iterate over the first time, and we're still going to create the angle, right? So we can do this, but instead of drawing the arrow right here, what we want to do is instead we want to just store it. So we can say, hey, in the grid, at this column, and at this row, I just want to store the angle. Okay? Just like this. And then we want to, we still want to draw the arrows because they're useful to see. So let's do that still. Do this. Whoops. Scala-cli indentation, thinking it's in the wrong place. Nice. This way. That's not the end of the name. Whoa. How many people here like Scala-cli's indentation-based syntax, out of curiosity? A couple people, all right. The one thing I don't like about it is what I just did there, when you're trying to copy-paste stuff and it totally blows up on you because it thinks you're not in the right stuff. Why is this freaking out at me? Okay. More indentation issues. All right, sorry about that. But, like I said, we're going to take some code to actually iterate through it one more time. So basically, this first for loop, we're doing what we said before. We're just assigning an angle. This second one, we're iterating it through it again, and we're drawing an arrow. So if I run this one more time, it should do exactly the same thing that we did before. Not that interesting. But so we want to start actually, like, instead of just drawing an arrow, we want to draw points along the arrows. And there's a couple of, like, first things that are important, I would say, that we need to define. We need to define where we start drawing this line. So, like, basically where the x is that we're starting from, the x coordinate. And we'll say 500, which will be, like, right in the middle of the screen, like the top of the middle of the screen. Because the y coordinate will, or y, which is also a double, we'll say 0, which would start right on top. The next thing we need to decide is, like, how long will the steps be? Like, do we want them to be, like, really close together? Do we want them to be really far apart? So let's start, like, pretty close together, and we'll say 10. And then we also need to define the amount of steps that we want to take, like basically how long is our line going to be. So we'll say we'll do this for 300 steps. And I'm going to, again, copy code because I'm running out of time already. We're going to do this. And here we have some more iteration, which I'll explain in 1 second. And then we also have to do another method to draw a point. So we'll see this one. And I'll explain the draw point one first. So we have our draw arrow, and nothing in the register, which is not what I want. Okay. Now here's our draw point. What are we going to do? Similar to the draw arrow, we want to just draw a different color point on our grid. So we want x and y coordinates, and we want to basically like take the old colors, store them, get new colors, the red stuff, make a point on that location and with some different stroke weights, and then restore the old weight and color. So that's all this point method is doing. It's not doing a lot. But up here, we are doing a couple of different things. So for the amount of steps that we want to take, aka like how long our line is going to be, we want to draw a point on the current x and y location. Then we want to get the offset, because remember, like our grid is 1,000 by 1,000, but it's actually a little bit wider and a little bit taller, so we want to make sure we're getting the offsets correct with those. And we want to figure out like where in our grid those are, which is what the column index and row index is doing here. This is a little bit of logic just to make sure that whatever we get, because some of those points may be off the actual grid depending on like how we're computing them. So this is just a little bit of safety to make sure we're not trying to grid something at like negative 10,000. And then we, again, are going to grab the angle, and then we're going to do a little bit of math stuff here with cos and sin. And this will basically be able to tell us what the next point should be in the curvature following the lines. And then we'll just assign the x and y to those next steps. So if I run this, you'll see that we actually have a nice line following the arrows from the top of the screen to the bottom of the screen. And just to show you, again, like some of the initial values that we picked, how much they do make a difference. Remember we said we picked 10 for the step length because we wanted them to be pretty close together. But if I would change this to 30, for example, you'll like immediately see like, oh, they're like much farther apart now. So if you were to trace this, you kind of have like a jaggedy line instead of a nice, really like smooth one. And same thing, steps. Like we took 300 steps, and the line is pretty long. Like if I change this to 30, for example, you'll see like our line is way shorter now. Or maybe I do 10, or it's more. Let's do 10. Run it again, and now we have like a very, very short thing. So like just with those few points alone, like where your line starts, how many steps you're taking, and what the step width is, you can like really change the way that lines or dots are being stored or being like drawn. Okay, so a couple things we want to do at this point. Again, this is still pretty boring, right? Like we're computing the angles and they're changing, but they're changing in the same way every single time. It's not actually like generating anything interesting. And we want to sort of distort the vectors. And distorting the vectors is something that you'll see done all the time when using flow fields, and it's almost like 90% of the time done in the exact same ways using something called per-lin noise. And it's just an algorithm that basically, like, it sort of is random, but it's not, because it uses like the values next to it to determine what that value is. So like if there's a slight curve and the value next to it, yours will, again, slightly curves based off of what that value is. Like there's some sort of continuation that happens there. And because it's like such a common thing, like processing actually has built-in support for it. So there's not a whole lot that we actually have to do to implement it. So if we'll go back up to where we're doing this grid here, we are just going to do a couple really small things. Instead of just saying, here is the grid, or here's the angle, we're going to get rid of these. We are again going to get the scale values, which is, the reason that we're scaling these here is that this noise, which is a per-lin noise method, the value that is returned will always be between 0.0 and 0.1. So we're basically creating that before we pass it in as well to have the same thing, and then we're timesing it by pi. We don't have to do 2, and then we're getting rid of this, and that's it. So again, pretty simple here. Scala. So like again, very small change. We're just going to use the built-in noise. And now if we run this again, now we have something completely different. And you can actually even see probably like that there's like flowy things going on. Except now, like we didn't fix our steps. So let's go back to 300 steps like we wanted, just to have a longer line. Let's make the step length 10 so those dots are closer together. We'll run it again. And there you go. Now you have a line that, like, if we keep running this every single time, it's going to show you something different every single time. Sometimes there's just a straight line. It's not that boring, or it's not that interesting. And sometimes it's somewhere else. If we also want like a little more action than that, we can times this by 2 to make a little bit more fluctuation in the flow graph. And now this is an interesting one because it starts where we can see it, but it goes off the grid somewhere else, so you can't really see it. So that's like a bad example, I guess. Still interesting. Same one, kind of not great. Do one more. Okay, so I think you get the idea. Like this is pretty interesting. But now let's do some like final small things to really like pull all this together. Because like believe it or not, like what we've done so far is like 90% of what you actually need to know to do a lot of the stuff that you saw in some of the bigger images. So the y and the x, like right now you will have noticed that like every single time it's starting at the same point, right? So like if I would change this to maybe 100 and do this again, it'll be more evident. Like it's going to start at that point every single time. We don't really want that, right? So we want to get rid of these because we don't want like predefined x and y coordinates. We want to figure those out ourselves. And we're going to refactor this bottom function, or this bottom for loop that we have here, to instead of just doing all this, what we're going to do, like, because again, like right now, it's just like we give it the values and it plots them out, but we want, like, we're going to refactor this out into a draw curve function. And what this is going to do is introduce, a little bit of random values, which is what you see here. Import random, yes. So we basically, now our x and y's are randomly computed. For every step, remember we have like a set defined steps. For each one of those, we're going to get the offsets, get the index, just like we did up above. We want to make sure that it's in the grid. We want to get the angle. We have some more math stuff here, just same as that we were doing before. And then we compute the next x and y, and then again we're drawing a point, and then we're defining the x and the y for the next iteration. Okay, so we can get rid of this one up here because we just refactored all of this out. And now the only other things that we need to do is, like, if we're going to generate a whole bunch of lines and we want them to start all over the place, we also need to like figure out how many lines do you want, right? So you can do val line count, and I don't know, we can do 1,000 lines to start. And then we basically want to iterate through those. So from 0 until line counts, for every one of those, for each count, what we're going to do is we're going to draw a curve. And what are we going to pass it? The amount of steps we want it to be, the count that we're on, and the step length between each dot. So if we run this now we see a whole bunch of stuff, but that's like too much. So like too many lines, basically. It's either too many lines or like it's too thick, right? So maybe if we scale this down to 100 lines and run this again. Okay, so that's a little more doable, but like it still like fills up the whole page. That's not really what we want. But it's still like something's maybe off. Like what could we do? Maybe like stroke width. Maybe that's it. Like stroke width is 10. Maybe that's huge. Like let's go way back down to 1 to have like little dots. Okay, that's too small. Like you can see them actually, but like now they're really slowly starting to come in. So maybe that's not what we want either. Maybe we do want 10, or maybe we want 5. I don't know. Let's try 5. Okay, it's a little bit better. But you also notice that like this is like continually rendering. Well, why is it doing this now and it wasn't doing this before? And the reason for this is now that for every single line that we're drawing, we're generating random values. And like before, we didn't realize it, but when we were plotting something, it was actually continuously on every tick plotting, but plotting the exact same thing. But now that we've introduced random starting points, you're actually saying like, no, this is constantly doing stuff. And if you wanted to actually like draw a picture, you don't really want it to do that. You only want it to do once. So what we can do here is we can say no loop, and this should stop the looping, and now we only get it once. So now you get sort of like your picture of what you want to do. But this is still dots, and this is not exactly what we wanted to do in the beginning. So what we can do here is let's turn this into some art basically. Like the arrow is dumb. We don't need to see the arrow anymore. I think everybody knows what the arrow is doing, so we don't need to see it anymore. Let's get rid of the draw arrows, which means we can get rid of this entire iteration, minimize it even further. Now if we run this, now we have all these without the arrows. That's pretty cool. Maybe like the gray is messing with the background a little bit, so we can also do background, maybe just make it black. Okay, so now we have red dots. We don't really want dots anymore, like plot dot, and we want to make a real line like we were talking about. So instead of doing draw point, let's get rid of that because we don't want to draw points anymore. And instead of draw point, we can just make a line, and it's actually quite easy because we have everything we need already. We can just we have the x to start it, so x to float, y to float, and hey, we already have the next stuff, so we can do next x to float, next y, to float, and there we go. Now we're doing lines. So if I do this one more time, and now we have all black. That's not what we want either. So maybe let's get rid of the black background, like I said, or like I thought we were going to do. So let's go back up to this. Where's this background? Get rid of that. Keep it white. Gray for now. Run it one more time. Okay, there we go. So now we have some lines, but that's kind of boring because there's not that many. So let's make maybe 1,000 lines instead. Ooh, okay, so now we kind of get the idea. We start to get this general flowy thing. And just for some really extra bonus points, just having one color is a little bit boring, so let's try to introduce a little bit of colors to this. Whoops. So if we go down to the draw curve, what we can do, because we have, I think we can do this. How about if the count is divisible by 2, then we'll make the stroke color one color. If it's not, then we'll make it another color, which will just give us 2 different colors. Ooh, okay, so you'll notice that this is a little bit too light, so maybe we want this to be a little bit darker. So I think we have stroke somewhere, stroke width. We can do stroke width rather, or stroke weight. We can make it 10. Okay. But you notice that there's still points. You can almost see the points still, which kind of bugs me. So the reason for that is this last value here is opacity, so we can get rid of those and just make them really vibrant. We'll run this one more time. Okay, so that's better. Maybe a little bit too many lines. So let's do 500 maybe. And now that we have these cool colors, we can actually do black again as a background. And there we go. Maybe still too many lines. Let's do line count 300. Okay, maybe 200. Okay, but I think you kind of get the idea. So a lot of these pictures that you see, these general concepts of how to generate something, come together pretty easily once you get them, and you realize that changing some of these small values, pretty easily, radically changes your entire image. if you'd rather read instead of what you just saw, because I know I like flew through some of this stuff really fast, I wrote an entire blog post, basically a blog version of what I just talked about, where I talk a little bit about like Tyler Hobbs' article, talk about his process, talk about taking his pseudocode and translating it to Scala code. And like I said, everything that I showed today is in that other repository, so you can run each example and see all of this stuff. And that's basically it. That's how I do this. I think there's one more. No, that's it. There's no more slides. So that's it. That's how you make flow fields in Scala with processing. Any questions? Steering.
Thank you for that.
Yeah.
So I'm wondering, so earlier I spotted push matrix and pop matrix.
Yeah.
And wondering how, so that language is familiar from the OpenGL API. And wondering how much of this, how much of processing is a layer on top of OpenGL? Is OpenGL relevant? Is it just a coincidence that the language repeats itself, or is the layer on top of OpenGL? Can you also use shaders? What's processing add on top?
Yeah, so the push, I might be totally wrong here, but I'm going to give you what I think is the right answer. But push matrix and pop matrix are general concepts. Like they're concepts that are through different generative, artistic platforms. Like any 2D type thing that's dealing with a grid, from my understanding, like this is like a pretty common concept to do, because like I said, like if we're going to do that same thing, like we had 1,000 by 1,000 grid, which meant that for every arrow we would need 1, 2, 3, 4, 5 points times like the amount of coordinates that you would need to figure out for every grid point would like expand like crazily, and it'd be really difficult to get it right. So any type of system that has a 2D grid that typically is rendering things within that grid in a static way, sort of, it's easier to just move the grid around than to compute that for every single thing. Because then you just have to do one shape, and just move the grid all around. So I don't think it's that processing necessarily is built on top of that, or one copy the other one. I think it's just like a generic 2D grid concept that is like pervasive across a bunch of different things, is my understanding of it. Because I also saw reference to this in other things. So I don't know if that answers your question or not.
Cool, thank you.
Okay.
Thank you.
Yeah.
So I noticed that processing seemed very imperative. Have you ever tried doing generative art in pure functional programming, and how did that go?
Yeah, so I first tried to do it with Doodle. Like, I don't know if you're familiar with Doodle or not, but Doodle is written on top of cats, so like you use IO instead. Like, it's kind of abstracted away, but like it approaches some very similar concepts with purely functional programming. But the difficult that I have a little bit with it is that translating some existing code to it when you hit on something you don't understand, like processing has such a huge community that like you search for something and you just like immediately find a bunch of answers for it. Where with Doodle, like you have to like dive into the code and really like figure out what it is. So at least the way that I'm approaching this is that a lot of the things that I want to experiment and play around with, I want to do the processing first, because it's like such a wide, there's so much information out there about it. And then once the kind of the concepts get solidified, I want to do this. I want to try to do the same things in Doodle. But also, like, Doodle's amazing, but I also don't think Doodle has the breadth that like processing has. Like, processing is pretty crazy. Like, there's a lot of stuff in there. And to be honest, like you can do stuff more functional inside of it processing. Like, yes, it's imperative. Yes, there's a bunch of mutation that's going on behind the background. But that doesn't also keep you from, computing a whole bunch of things and then not mutating them all over the place and then passing to the draw methods. So. Cool. Again, thanks so much.
Brilliant. Thanks so much.